Hello kids, welcome to my channel Science and Compass, and this is your first chapter in physics for class 9th. You can use the timestamp to access individual topics under this chapter at your convenience. Do not skip anything in this video, and last but not the least, do subscribe to my channel to get the latest notifications. Now, without wasting any time, let's begin our chapter number 1, Motion. If you look around you, you will find practically everything is in motion. If you look at a stone, you may think that that stone is at rest, but in reality, its atoms are in motion as well. Can you think of any other objects? How about blood flowing in your veins, birds flying, people walking or doing some work, cars moving on the road, planets orbiting our sun? Well, the sun itself is in motion around the galactic center of our Milky Way galaxy, and all the galaxies in our universe are moving further away from each other as our universe continues to expand. This, by the way, is a scientific fact. So as you can see, everything is in motion. We often perceive an object to be in motion when its position changes with time. So what I mean by that is that if an object was in some, let's say, X position, and after a few seconds you find that in a Y position, you can say that this object has changed its position with time and has shown some motion here. However, there are situations where the motion is inferred through indirect evidences. What do you mean by indirect evidence? Well, for example, we can infer the motion of air by observing the movement of the dust, movement of the leaves, and movement of the trees, or you may observe the movement of your kite to infer the motion of air or wind. So these are all through indirect observations. An object may appear to be moving from one person for one person and stationary for some other person. For example, when you travel in a moving bus, you would get a sensation that the roadside trees appear to be moving backwards as your vehicle moves forward. Same holds true for a moving train. Many times we would wonder who is actually moving here. Was it your train or the one next to yours? A person standing on the roadside, however, perceives the bus along with the passengers as moving. But a passenger inside the bus, how would he perceive it? He would see that he's at rest and all the passengers in the bus are also at rest and they are not moving at all. So motion is relative, and this was made popular by people like Albert Einstein and Galileo. So some objects may move in a straight line. Can you think of something? Maybe a train. Others may take a circular path like the earth around the sun. Some may rotate, like how the earth rotates on its axis, and a few others may vibrate, such as atoms. Or there may be situations involving a combination of all these types of motion. Now we will talk about motion along a straight line. So, motion along a straight line. Alright, so in this video you will come across certain words such as distance, you will come across magnitude, you will come across displacement, so these are the words that you will come across, and let me try to explain one by one. All right, so let me just put this up a little bit so you can see. So distance, what do you mean by this word distance? In physics, distance is the physical length through which an object travels. All right. So for example, Let's just say that I have a ball right here, and it is at some position. This is the starting position. So we will just give it some number over here, some numerical value. So we will just say it is at some 0 meters. Okay, and I would just kick the ball. That's me kicking the ball, and the ball will travel at some distance and stop right there. So this was the initial this is the initial position of the ball, and the final position of the ball would be over here. And this whole it would have covered around a distance of let's just say 10 meters. So let me just put the numerical value 10 meters. All right, so this was the initial position of the ball, and now this is the final position of the ball. So you can put a little I over here just to show what this one is. This is the initial position, and we can put an F. It is the final position. Now this is the distance. So the ball has traveled a distance of 10 meters. And that's what the distance is. It's a physical length through which an object travels. That's distance for you. Okay, so let me just tick mark that one. Now coming to the next word, magnitude. Okay, so what is magnitude? Now magnitude is nothing but the numerical value of a physical quantity. All right, so that's the magnitude. It's just the numerical value. It is just a number. All right, so in this case, in our previous example, the number is 10 meters, and that's the magnitude. All right, in our previous example here, so the answer was 10 meters. That's the distance that the ball has traveled, and that would also be the magnitude. All right, so we're done with what a magnitude is. Now comes to displacement. So what do you mean by the word displacement? Displacement. All right, so that is just the shortest distance measured from the initial, just remember this word initial, okay, to the final position of an object. All right. All right. So let's just give you an example of displacement now. So just imagine that you are standing over here. Okay. All right. This is your initial position, IP. So now you will walk down, okay, at some position over here. Okay, this is your position number A, which is your initial position, and this would be your other position B. All right, now the distance between your initial position and that position, I'm not going to say B is your final position. It's not final yet. Okay, in this example, you have somewhere else to go, so I'm not making B as the final position. So the displacement, I'm sorry, the distance between the initial position and B, okay, the distance between A to B, let's just say is some number. You can just give some number. But before I can do that, let me just mark it so that you would know. at some point, this is O, this is 0 position, so this would be, let's just say 10, and then this is 20, this would be 30, this would be 40, okay, this would be 50, and this would be 60, okay, 60 kilometers, let's just say. So from A to B, just walking from A to B, you are covering a distance of 60 kilometer. Okay, so that's your distance. That would be your distance. So I'll just make it, first let me just write down what your distance would be. That is just AB, which is nothing but 60 kilometer. Okay, good. So let me just put it right there. Yeah, over here. But it turns out that you would want to turn around and come to this spot right there. All right. So I have already coded this as A and this one is B. So let me just put this as C, just so that you know this is C. And you're stopping right here. So C turns out to be your final position. Okay, that was your initial position. So let me just write down the word, complete word, so that you know initial position. All right, so we're still not done, because in this example I have just given the distance AB, but it looks like you have taken a turn and you have come to C. Okay, so AB is already 60, you have already covered 60, plus you have to cover that B and C, so just make it as plus BC. So what is BC? What is BC? So this is 60, and you're coming back here to this spot, which is 30. Okay, so the distance between B and C is nothing but 60 minus 30. 60 minus 30 is just 30. So you just add another 30 to your total distance. So I hope you got this. 60 kilometer was the initial one from A to B. 30 kilometer is B to C. All right. So now what's the total distance that you have covered, the total length that you have traveled? 60 plus 30, you get 90 kilometer. This is your total distance, right? This is your total distance. Now we're talking about displacement, remember? Yeah, we're talking about displacement. So let me just draw a line over here. So displacement, and the mathematical formula for finding out displacement, all you have to do is know your final position and you subtract that with your initial position. So where is your final position? Your final position is at 30. Okay, your final position is at 30. This is your final position. You can just write it as 30 over there. Okay, that's 30 kilometer, minus your initial position is just 0 because you started with 0 kilometer. So you can just write 0 kilometer. So 30 minus 0 is just 30. This is your displacement. What do you mean by that? The displacement is from this spot to this spot. This is your displacement, the shortest distance. Okay, the shortest distance measured from the initial to the final. Okay, that's the distance. That's the measurement for displacement. But the total distance would be the total length that you have traveled, which is going to be much bigger. So you went all the way from A to B, from B to C. So you added 60 kilometers plus 30 kilometers, then you got a 90. The total of 90 kilometers is how much you have walked. Okay, but when it comes to displacement, as the definition goes, the displacement is just the shortest distance that you measure from your initial, which is 0, to the final, where you stopped walking. That's your final position. Let's just say that you're just standing there now. Okay, I cannot draw another figure there because it looks so crowded. But imagine that dummy figure right there. You place that dummy figure here as well. So that is, one is your initial position and this spot would be your final position. And we need to know the distance between both of them. And that is what is called displacement. Okay, so displacement equals final position minus initial position. Final position is at 30 kilometer. You can just write 30 there, minus 0 kilometer for the initial position. So 30 minus 0, you just get 30. So that's your displacement right there. Okay, so this was with an example of what a displacement is. Now there are a few things that you should keep in mind. I already told you what distance is. So distance is just a physical length through which an object travels. Now a few things that you should remember is that distance can be greater or equal to displacement. Okay, what do you mean by that? Distance can be equal to displacement. Distance can be greater to displacement. Okay, now again a small example, the ball. Okay, the ball right there. So this is the initial position A, and you just kick it and it goes right there. This is the final position B. Okay, that's it. This is the initial, this is the final. The total distance would be, I don't know, let's just say 10 meter. That's the distance. The distance would be 10 meter. The displacement will also be 10 meter. Why? Because we already know, keep in mind, displacement means the final position minus initial position. So the final position is 10. Okay, the initial position was, we began with 0. So 10 minus 0 is just 10. So you got the distance 10, you got the displacement 10. That's why they say that distance can be equal to displacement. Okay, but distance can be greater to displacement. How can the distance be greater to displacement? We just saw in our previous example right there. You see that? The distance is greater than displacement right here. Okay, so this is for point number 1. And now going to point number 2, distance cannot be 0, but displacement can be. Displacement can be 0. Okay, now I'll just give you an example again. Okay, so let me just take another color. All right, so distance cannot be 0. If you want to travel from point A to point B, you cannot just say that I traveled 0 distance. It has to be some number, maybe 10 kilometer, 20 kilometer, 300 kilometers, whatever, or miles, or whatever the units that you wish to use, you can use it, but you cannot say that I traveled 0 distance. Okay, that's why distance cannot be 0. Okay, but displacement can be 0. What do you mean by that? Let's just say that you travel from A to B at 10 kilometer, and again you turn back and you travel from B to A, back to where you began. Okay, so you started initially at some 0 kilometer and you traveled all the way here at 10, and then again you turned back and traveled all the way back again 10 kilometer. You traveled all the way back again over here. So the distance is going to be 10 plus 10, which is just 20 kilometer. That's the distance. That's the distance. Okay, but displacement, well, we know again with our formula, displacement is nothing but the final position minus initial position. So the final position, well, you came back again to 0. So final position is 0 minus you began with 0. So 0 minus 0 is just 0. That's why they say that displacement can be 0. But distance cannot be 0. You cannot say that I traveled 0 distance. You can say that my displacement can be 0, but you cannot say that my distance can be 0. Okay, so you need to keep these two in mind. Question: can the magnitude of the displacement be equal to the distance traveled by an object? Okay, this is my question. Can the magnitude be equal? So what is the magnitude? As I told you, that's just the numerical value, the number. So can that number of the displacement be equal to the total distance traveled? In our previous example, we saw that it can be equal. Sometimes it's the displacement can be equal to the distance, and other times it has to be shorter, okay, than the distance, the total distance. Okay, so let me just give you another example over here. So I'm just drawing a line like this, okay, and we begin with 0. So this is O, and this is O. We begin with 0, okay, 0 kilometers or whatever, and we have marked numbers over here. So that's 5 kilometers, 10, 15, then there's 20, then there's 25, 30, 35, then we have a 40, 45, 50, 55 and 60. So let me just stop it right here. Okay, yeah, so I just have to do this one more time. 1 minute. Okay, so here we are. Okay, so this would be, let's say, A. All right, we started with 0 at O, position O, and this is the last position A, which is at 60. So the question is, can the magnitude of the displacement be equal? Okay, let's just say that the distance, let's find out how much the distance is, then we'll look at the displacement. So this we know, from 0 to 60 kilometers, that's the distance. So you write as 60 kilometers. Okay, now what is the displacement? So just write down the word displacement. Okay, this is the initial position, okay, of that object, and this A is the final position of the object. So with our mathematical calculation, we know what the displacement would be. Displacement is just going to be the final position minus the initial position of that object. So this was 60, final position over here. I'm just looking at this number, 60 kilometer minus 0 kilometer, and you're just going to get 60 minus 0 as 60 kilometer. Okay, so as you can see, our distance was 60, our displacement is also 60. So here we can say that the magnitude of the displacement can be equal, it can be equal to the distance traveled by that object. So it is equal here. Even the distance is also 60 kilometer, the displacement is also 60 kilometer. All right, so now I'm just going to erase only this part, because I need this diagram over here as a reference. All right, now in our example, let's just say now that this object, whatever that object is, maybe it's a rabbit or a horse or whatever. So let's just say that now the object travels from O to A and back to B. Let's keep this one as B now. Okay, So this object will go all the way, I'll just color it with yellow, from 0, from this O position, it will travel all the way to A, turn back and come to the final position B. Okay, you already know the total distance covered. Okay, the total distance covered, you have to make it as O to A plus A to B. So let's just do that. O to A plus A to B. So O to A is what? From here, O to A is 60. You can see that right here. It's 60. So we'll just write it as 60 kilometer plus what is the distance between A to B? We already know this numerical value is already here, 35, but we need to know the distance between A to B. The distance is 60 minus 35. Okay, 60 minus 35. You are going to get an answer. Let me just put it here. 60 minus 35, which will give you the answer as 25 kilometer. That's what you're going to write over here, 25 kilometer. Okay, let me just erase that. So once we get this, O to A plus A to B, that is 60 kilometer plus 25, that's the distance between AB. Okay, that's the distance between these two, right? So that you got the number as 25. Now you add them, you get an answer 85 kilometer. That's the total distance. All right, now you know what you have to do. The next one is that you need to find the displacement. Let us see if that's going to have the same number, same magnitude. That's the question. I'm sorry, not the distance, but the displacement. Okay, that's the displacement. What is the displacement? Don't think too much in this. The displacement, as we know, is just the final position minus the initial position. What is the final position? We just stopped it at B, right? We just stopped it at B. That's this, B. And what's the number written over there? 35, right? That's the number 35 right there. You take that, that's the spot where we have stopped, 35. Okay, that's the final position, and you subtract that with the initial position, which is nothing but 0 kilometer. We started with 0. So 35 kilometer minus 0. Okay, so let me just write that down. 35 kilometer minus 0 kilometer, which is nothing but 35. As you can see, the distance is 85. That's the total length that object had to travel. The the displacement is the shortest distance measured from the initial position to the final position of an object. All right, and you can see that number is smaller. This is a smaller number. This is what you get, a smaller number. All right, so that explains the final, what is the verdict? Well, let's just go back to our question over here. What was the initial question? Can the magnitude of the displacement be equal? Yeah, it can be equal, and I've shown you right here. Oh, by the way, not here, but I had already shown it to you. If you can just kind of go back and see the video, you can see it because I have already erased that part on the board. So you can see that the displacement, the number of the displacement is equal to the distance traveled. But in other cases, it can be smaller. The magnitude of the displacement is smaller to the distance traveled. And here I have shown you how that can happen. All right. So I hope you are clear on this part. So basically, Distance is nothing but that physical length through which an object travels. Okay, distance can be greater or equal to displacement. Distance cannot be zero, because if you have to move from point A to point B, you cannot have a zero value. There has to be some value, okay, whether it is 5 centimeter, 5 kilometer, 5 meter, whatever, but there has to be some value. So distance will always have a numerical value. It will not be zero. So distance cannot be zero, but the displacement can be zero. And how is that? Well, in the same example, let me just say that I don't stop here. Okay, I don't stop here. Let me just erase this. I don't stop at B, but I just continue and go back to my initial position right there. Then what is the distance, total distance traveled? Well, it turns out that I travel from O to A, which is nothing but 60 kilometer. Now I have turned back and I'm traveling back from A to O, which gives me another additional 60 kilometer. So 60 kilometer plus 60 kilometer is 120 kilometer. That's the distance. But since I've come back to that, you know, the same initial spot, yeah, my displacement is going to be zero. Okay, because displacement, as you know, that's the final position minus the initial position. The final position is 0, initial position is 0. You subtract 0 minus 0, you just get a 0. So displacement can be 0, but the distance cannot be 0. All right, so I hope you enjoyed this video. Do let me know if you have any questions, and I'll try my best to answer them. Thank you. So now we will be talking about uniform motion and non-uniform motion. So what is uniform motion? Any object that covers equal distance in equal intervals of time. Okay, so for example, in this in front of you, in front of the screen, you have a car. Okay, but in real life it really doesn't go that way. But imagine this car is traveling 5 meters in the first second, 5 more meters in the next second, 5 meters in the third second, and 5 meters in the fourth second. So you have an object which is moving at equal distance in equal intervals of time. And when an object covers equal distance in equal intervals of time, it is said to be in uniform motion. But in our day-to-day experiences, we really don't come across uniform motion. So for example, this guy, this person who is jogging, he is jogging randomly here and there. So it's not really at a uniform motion. Okay, so various objects cover unequal distances in equal intervals of time. So this person is jogging and another person is getting chased by a bear. So these are the examples of non-uniform motion.